So tonight I'm going to talk about web components, and I'm going to talk about some reasons why you'd want to use them and how you can use them in your apps today. So for those of us who aren't familiar with web components are not actually a single thing. They're actually a collection of APIs that make up what is called the web component specification. So what this specification is it just opens up low-level browser APIs that allow developers to author components that can run anywhere on the web. And as far as I can tell, there has never been a better time to explore web components than write Meow. A quick search on can I use, A quick search on, that's better, on can I use, on can I use shows that Shadow DOM, one of the web component APIs, is supported or will be supported by every major browser except for our dear friend IE11. It'll even be supported in Edge shortly once they switch over to Chromium. Shadow DOM is what gives us the ability to write encapsulated HTML and CSS, so we don't have to worry about external code changing anything that we've written in our components. Another major piece of web components is the custom elements. Like Shadow DOM, they will be supported soon by every major browser except, again, our dear friend IE11. Custom elements allow us to register web components as a DOM element, so we can just instantiate our code wherever we can write HTML. So web component browser compatibility is strong, but aside from the strong browser compatibility, web components also happen to be great conversational topics at parties. If you bring up web components, you will definitely attract a crowd faster than you could say micro front end. The problem, though, with web components at parties is that they kind of tend to be a little bit polarizing. Take this, for example. So here's an article that was on dev.to. It enumerated all the reasons why web components are great and how they fit into the author's use cases. And so after reading this, it's really hard to imagine building anything without web components. They just solve every single problem, meet every use case, no need to look further. But this was actually a rebuttal of another article about how we don't use web components. This author argues that web components haven't brought much value to the table at all, and that they've actually just kind of resolved problems that have already been solved by component frameworks like React and Vue and other user-land component architectures. From my perspective, I think both of these viewpoints are actually valid. Sometimes web components are the right tool for the job, and sometimes web components are the exact wrong tool for the job. And so just like any decision we make in engineering, we have to evaluate our use case and look at the trade-offs when selecting which tool to use, and there's no difference here with web components. So a couple of reasons why we want to use web components is we would want to write UI that can be used anywhere regardless of the framework. Web components allow us to write truly interoperable HTML elements. If we want to protect and encapsulate our DOM and CSS so that we can safely refactor our code even after we've shipped to consumers, web components are a good fit for that. If we need access to some low-level APIs that directly extend HTML, one example might be a synchronous mutation observer. Web components allow APIs to do that sort of thing. And if we want our code to be really easy to be consumable, one nice thing about web components is the way we ship them is as HTML elements. So if you know HTML, you can definitely use web components. On the flip side, if your primary use case is building large-scale applications with lots and lots of data and shared state, web components are not a good fit. There's no concept of state management. There's no routing. There's no virtual DOM, batch rendering, declarative rendering, or anything like that. It's very imperative, and there's a lot of boilerplate. I think in order to implement one attribute, it takes about 20 lines of code, which is a lot of code. Very error-prone. I like to view these trade-offs in two ways. One, web components are low-level browser primitives. So if you're interested in doing something really low-level that can be shared across different applications, web components are really, really good for this, especially if you want to do a UI that is to be distributed. The second piece is web components do not replace your framework. You aren't going to take your React application and rewrite it in web components. The problem is that they're far too low-level and verbose to build a new app with. And so looking at these trade-offs, you probably don't want to use web components for that. But there is a middle ground. If you already have an app that's written in React and you want to take some of the pieces and move them to web components, there's a really good migration path where you can get started. So where I like to get started with migrating to web components is actually with leaf components. And a good place to look for this is in design systems. So what a leaf component is kind of like the lowest level component in your tree. They typically don't have any children. The data is usually passed to them. They're not managing any state. They're just kind of receiving things. And so if we were to build a design system, it's meant to be used on any website, and we care about interop, and web components would be a good fit for that. So for our first component, I wanted to take a new take on an old classic and make a slider that just replaces the boring gray circle with a kitty face. We could have used any emoji, but cats are great. So there's really nothing particularly complex about this. It took about 38 lines of CSS and 1 input range. And it is, of course, entirely possible to build this without web components. So web components are not necessary to build this out of the box. But if we didn't use web components, there's a couple drawbacks. First, our 38 lines of CSS, there's actually no guarantee that external code from another developer or an errant selector on a pull request wouldn't actually break our component. So for example, we have this CSS, which just takes an input, it targets all inputs with a type of range and uses the pseudo selector. This is a really broad and generic selector, and it would be really easy to overspecify this. And so if somebody were to commit code and then turn this into a frown face, that wouldn't be good. The frown face is a different component. We don't want it to mess with this. Another way to think about using web components for design systems is how do we actually instantiate this? How do we reuse this? We have a couple options. One, we can use just a vanilla function that takes a container element as an argument. This is easy to use, easy to reason about. We just pass a DOM element, and then inside the function, we create our input, we put the CSS on the page, and we just have what we need. But the drawback here is having to import and invoke a function for every usage is not very ergonomic. It also would be really difficult to let this work when you're setting inner HTML, for example. Another option is we can use React, Angular, Vue, Svelte, Ionic, LWC, any other framework component of choice. This is great. We have great component reuse within the framework. We get to take advantage of the component library ecosystem. And generally, these frameworks are really well documented, so it should be fairly easy to do this. The problem is that our cross-framework interop is an issue. We might have to implement one component per framework, which introduces fragile code because if requirements change, we have to change this across everything. And another way we could do this is we can make a React component that runs in Angular or one that runs in Vue, and it just gets really crazy. There's a lot of work we have to do if we wanted to implement this across boundaries. So what we can do instead, if we were to implement this as a web component, we can just extend the native HTML element, just like an ES6 class. We'll call super so that we get the HTML element goodness. We'll take our web component, we'll attach a shadow root. So this will give us the CSS encapsulation and HTML encapsulation that we're looking for. We'll just put all of our styles and all of our input tags in the shadow root there, with incorrect indentation, of course, just to make a pull request go crazy. And then we'll take that code and we'll define it as a Meow slider. Whoops. Hey, all right, define it as a Meow slider. So now what we can do to use this component is just import our code as from a script tag. And now anywhere we can insert HTML, we can just insert this Meow range. Wrong tag name, but you know, get the idea. We can also use this wherever we can use document.createElement because we've told the browser what our component is made of. One other benefit is that our slider is framework agnostic, and so it can be used by any client-side framework. We can embed this in Vue, in React. We don't need to have 4 different versions of our component just to run on 4 different frameworks. So we get true interoperability. So there's a lot of other use cases for web components. A couple more that I can think of are secure enclaves. If we have a credit card form on our site that we don't want a malicious script to get access to, we can easily hide that into a closed root shadow DOM. That'll guarantee security for our users. We could also, like I mentioned, do a synchronous mutation observer using the connected callback to just dispatch an event to listen when elements are being inserted. But in conclusion, web components are really not a fit for every use case. They're not meant to replace your frameworks. They do unlock browser primitives that extend HTML. We can write safe encapsulated HTML and CSS and get interoperability across the web. And as web components get more and more popular, I'm really excited to see what you all build. That's it.